Hello everyone, this is Aryan Sharma from Being Versatile and I am here to show you how to calculate the molecular mass of all elements using their atomic mass, a method that you can absorb in just 5 minutes. So let us see the formulas. Some abbreviation we are going to use in this video is A as molecular mass and Z as atomic mass. I hope you already know that. So let's get started. Here's our rule number 1. For elements lying between Z as 2 to 20. For perfect square like 4 and 9, A is equals to 2n plus 1, where n is equals to Z, that is atomic number. So let's take the example of beryllium, which has an atomic number of 4, which is a perfect square. So the molecular mass of beryllium, that is 9, which we can directly calculate from this formula that says A is equals to 2Z. That means 2 into 4, that's equals to 8 plus 1, that's 9. In this case we have an exception, which is the atomic number 16, which is oxygen, which has an atomic mass of 32. For even number, A is equals to 2n, where n is equals to Z, or simply A is equals to Z. In this case also we have one exception, that's argon. A is equals to 40 and Z is equals to 80. For odd number, A is equals to 2n plus 1, where n is still Z. Exception nitrogen, and with atomic number as 7 and molecular mass as 14. So let's take an example of even atomic number, that is 6, carbon, and molecular mass is 6 into 2, that's 12. For odd number, let's take an example of boron, that has an atomic number of 5. 5 into 2, 10, 10 plus 1, 11, and yes, boron has molecular mass as 11. So let's go to rule number 2. For elements lying between Z as 21 to 30. For even, A is equals to 2n, where n is equals to Z plus 2. And for odd, A is still 2n plus 1, where n is equals to Z plus 2. Both of the case we have one exception. For even, exception is Z is equals to 28, which is nickel, and for odd we have exception Z as atomic number 21, which is scandium. So let's take an example of both. Let's take iron, which has an atomic number of 26. So for the molecular mass of iron will be 26 plus 2, 28, twice of 28, that is equals to 56. For odd numbers, let's say atomic number 23, which is vanadium. So 23 plus 2 will be 25, and the twice of 25 is 50, and 50 plus 1 is 51, and vanadium has molecular mass as 51. So let's go to our last rule number 3. Now it is important to know that the atomic mass between 2 to 30 are most important, and hence you must know them all by heart. And definitely I hope you all know that atomic number 1, hydrogen, has an atomic mass of 1. So let's go to rule number 3. For elements lying between Z as 31 to 47, A is equals to 9 by 4 into Z plus 2. For elements lying between Z as 48 to 55, A is equals to 10 by 4 into Z, that's atomic number. For elements lying between atomic number as 56 to 72, A is equals to 10 by 4 into Z, and for elements lying between Z as 73 to 118, A is equals to 10 by 4 into Z. For elements lying between Z as 56 to 72, A is equals to 10 by 4 into Z minus 2. I think that I just forgot to tell minus 2, so I'm repeating that again. And you might wonder why there is an approx written beside them. That's the reason, because from these elements 31 to 118 has quite a lot variation. So approx here means like if the atomic number Z is near to 13, you can write the molecular formula as 9 by 4 into Z plus 1 plus 0.5 or whatever to fix the decimal value, and hence that is why we have put 2 or approx for that. If the if the atomic number is near to 47, you can keep it as 2, 1 or 1.9 or whatever that will fix the decimal place. As generally while giving exams and other stuff, we prefer to use molecular mass as well as atomic number, which is atomic number are actually whole number, molecular mass as whole numbers only. Thank you. I hope you all understand really well all these rules for molecular mass of elements from 2 to 118, that is all elements. I don't think I have to include hydrogen as it. Hydrogen is quite common, and that's all the rules. So let me shorten it. These are all the 3 rules. I hope you have liked it, and if you really like the video, please like and share your experience in the comment section, and don't forget to subscribe for more ideas on chemistry and how to easily learn the various things in chemistry. Thank you and have a nice day.